What's up, Internet? Welcome to Chyld Studios. In today's video, I'm going to be talking about the functor. Now, when you're talking about functional programming, the word functor can come up a lot, and so it's good to be able to understand what it is and what it means. So I'm just going to go ahead and get into it. Now, I'm going to be using the Ramda library, the Ramda JavaScript library, to illustrate this. But the concept of a functor really is generic in functional programming, so it doesn't matter if you're talking about Haskell or Scala or F sharp or whatever, any type of functional language. Functor is just a concept that's used inside of that. So I have right here on this page, on this web page, the map function, and the map function in Ramda uses functors, and so that's sort of how I'm going to start out this conversation. I'm going to go ahead and draw some things for you. So before I start talking about functors a little bit, it's good to understand like type signatures and how type signatures work. Let's say I had a function that took in a number, and it returned, it did something and it returned a boolean. Let's say it was some sort of filter where a number came in, and if it was true or false, if it was even or odd, it would return a boolean. So what this type signature would look like is you have a number and then an arrow, and then boolean. So that means number is the input, and number is the type. That's the type of the input, and then boolean is the type going out of the function. Let's say you didn't know the type of the input. It was just some type was coming in, but a number was coming out. You would say like a arrow number. That means you're gonna have some value, some type. You don't really know what it is, but it could be multiple things. But the type going out is a number, or maybe you have an array of something. So what would that look like? Well, you could have a bracket A. That means an array of something, and then you could output it. Let's say the output is like an array of B's. So this is like a map function, for example, where you pass in an array of somethings and you output an array of something else's. So these are examples. This and this and this are examples of function signature types. And this is common, like you'll see this a lot in Haskell. So it's good to know this before I start talking about functors. So let me describe the functor type definition. So this is what it looks like. Functor f is a arrow b. Hold on. Try that again. A arrow B, and I'm going to just change colors here just so it's kind of obvious what's happening, and then I'm going to go back, and this is F A, and I'll change colors again, and then I'll go F B. So this is the definition here. This is the definition of map. So this is map. Now to prove that, we can go back here and you can see that what I just wrote is the same thing here. So this can be very confusing, like this signature right here. So I'm going to explain what that means. So map basically takes two arguments. So let's see. So this is an argument, and then this is an argument too, and then three, and then this last one right here is the output. Well, let's call this I guess 3. So 3 is the output. So one, it takes 1 and then 2 and then 3. So the question is, what is 1? Well, 1, uh, this 1, what is that? This is a function. It's a function that takes in some something of some type, A, and then returns a value B. So it takes in something, and let's say let's say A is an integer, and it returns a boolean, or it takes in a boolean and returns an integer. We're not actually specifying the types here, but it's just saying whatever A is, it's going to return whatever type A is. It's going to return a different type. Now, it doesn't necessarily have to return a different type. Like you could actually have a square function that would take in an integer and return an integer. But this just means it could return the same type or it could return a different type. So map takes this is like a transformation function, something that transforms basically here A's into B's, transforms A's into B's. And then the second thing it takes, this thing right here, so FA, what is F? Well, F here is this. F is the functor. So now the question is, well, what is a functor? Well, a functor is basically just, think of it like a box, like conceptually, think of it like a box. I'm just going to draw an arrow down here that contains values. So let's say I had a 1 and a 2 and a 4 and a 9 and a 16, whatever. So this is a box that contains a bunch of values. If this box can be mapped over, I'm going to ask a question right here. If this box can be mapped over, if that's true, then this box here is a functor. So the functor is just something that can be mapped over. And map just means transformed. So if you want to transform something from numbers like a 1, 2, 3, whatever, into their squares, into their cubes, if you want to transform strings into objects, objects into an object into a number into a boolean, whatever. If you want to do some transformational thing, that's a map. And so maps work on containers that contain values. So if you have a container that contains a bunch of values and it can be mapped over, then that's a functor. So what this is saying, so back to this type signature here, this FA, basically FA right here, it basically just means some functor, some sort of container that contains a bunch of A's. That means some types of type A, that can be whatever you want. And it will return, and here in step 3, it'll return a container of B's. So this basically says I'm going to have a container of A's, and I'm going to transform this container of A's with this transformational function. So I'm going to take this container here, I'm going to transform it with this function, and then after the function's finished transforming it, now I'm going to have a container of B's. And then you can then map this container of B's. So this container of B's, I can then map that again and create a container of C's, and then a container of D's. So these maps allow you to chain. So you can have a container here, and then by mapping, you create another container, and then you can map that again, and then you can create another container, and then you can map that again, create another container. So all these things, this thing, this thing, this thing, and this thing, these are all functors. Right? That's basically an array of functors, meaning like an array of arrays. But in JavaScript, the only thing that you can map over is arrays, but in Ramda you can actually map over arrays and objects. I'll show that here. So right here it says Ramda provides a suitable map implementation of array and objects, so you can map over arrays and objects. So I hope that was illuminating. I'm going to give a small example of how to do this in practice. Okay. So here I have a Node application. I have Ramda installed, and I'm just going to write some code here. Okay. Well, you need two things. You need a container, something that you can map over. That's what a functor is, and then of course you need some transformational function. That's the function that will transform f of a's into f of b's. So let's create this transformational function. So I, in the past, have done simple functions like square or cube or add or whatever. Let's do something slightly more complicated. Let's do factorial. So let's say I have a function called factorial, and what it'll do is it'll take some value n, okay, some value n, and if n is equal to 0, so this is a quiz, what is the factorial of 0? It's 1. If n is equal to 0, then it's 1. Else, I'm going to take n times the factorial of n minus 1. So this is a recursive definition, right? This is the what's called the base case, and then this is the recursive case. Yeah, so right here we're just doing a recursive function. Yeah, using arrow syntax. This is some ES6 stuff. Oh, great. So now we have this transformational function here. Now we need two things. Well, we just need a functor. A functor is just like I said. It's a container that can be mapped. So in JavaScript, well, using Ramda, you can have that could be either arrays or objects. So let's create an array. Let's call this thing nums, and we're going to use Ramda's range. So I'm going to go from 0 to 10. So this is going to be 10 values. 10 is actually exclusive, so it actually goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It doesn't actually include 10. So this will give me 10 values since I'm starting at 0. So that's basically an array of numbers. And then let's create an object, and then let's call this A. A is say 0, B is 1, C is 2, D is 3. Okay, that's fine. Okay, so I have an object and num. So both these things are actual functors. So now I can apply this transformational function to it. Let's do that. So I'm going to say const, let's call this output 1. And I'm going to call ramdas.map function, and it takes, if we go back to the definition here, remember it takes two things: a transformational function and the functor. The transformational function and then the functor. So the transformational function is factorial, and then the functor is nums. So that's the this is the actual functor here. Okay, so there's output 1. Let's just call this O1. We'll call this O2. And then here we'll map over this object. And then finally, we'll just output the results. So we can see them on the screen. Okay. And then let's take a look at these values here. So there we go. So O1, so 1 right there, that's the factorial of 0 is 1, the factorial of 1 is 1, the factorial of 2 is 2, 3 is 6, 4 is 24, 5 is 120, etc. And then here, this object, this is the 0, this is the 1, this is the 2, this is the 3. So you can see here that Ramda actually mapped over both the array and the object. So now you could actually take this array and you could map it again, or you could take this object here and you could map it again. Why? Because both of those, the output of a functor is another functor. Once again, the output. So this is a functor is the input. This is another functor is the output. But it has to have the same shape. It has to have the same shape. So if 10 values come in, then 10 values have to come out. Here there were 1, 2, 3, 4 properties, so you have to have four properties have to come out. So it has the functor has to maintain the same shape. Anyway, that's it for this lesson, for this video. Hope you've enjoyed it. I'm going to be doing more videos in Ramda and functional programming. And anyway, that's it.